Hello guys, welcome back to my channel. So in this particular video we are going to learn about probability. So I have prepared a few notes related to probability. So I will go through these notes and I will try to make you understand of these concepts. Okay, so let's start. So first thing is, what is probability? So probability is likelihood of something that will occur. Okay, so probability of an event is equal to outcomes that meet our criteria by all possible outcomes. So if you like, I'll give you a simple example here. Suppose you toss a coin. Okay, so what is the probability that you will get head? So tossing a coin will have two possible outcomes. One is head and other is tail. So our criteria will be getting a head. So in that case we'll have one criteria that will be fulfilling, right? So head will be our criteria. Then all the other possible outcomes are head and tail. So the probability of getting head while you toss a coin will be 1/2. Okay, so there are two concepts. One is experimental probability and other is theoretical probability. So theoretical probability is our actual probability which we know for sure, and experimental probability is the probability that you don't know. And what you do, you run some experiment and you try to find the probability of occurrence of that particular thing. Suppose you don't know that while touching a coin you will get head or tail. So in that case you take a coin and you toss it for multiple times and you count like how many times you are getting head, right? So in experimental probability there is one concept called the law of large numbers. So if you run the experiment for very infinite number of times, the experimental probability will be close to theoretical probability. Okay, so here is a simple line. So suppose your probability comes between 0.5 to 1, then you will be more likely getting that item. The likelihood of occurring that item will be greater, right? So if the probability value is between 0 to 0.5, so in that case the probability of that item will be very less. So here is the formula that will be favorable outcomes to all possible outcomes. This is the simple formula and you have to remember this. So next thing comes is your addition rule. Okay, so there are two rules basically. One is addition rule and another one is multiplication rule. So when you have to apply addition rule, so if the probability of something will be A or B, in that case, so you can see here you will apply addition rule. Okay, so the addition rule is here. So it will be like probability of A plus probability of B minus probability of A and B. So this A and B is nothing but is your intersection part. You can see here. Okay, so if I give you a simple example here, suppose you toss a coin 2 times, and what is the probability that you are be getting at least one head? So if you see in the first, what are the possible outcomes? Let's see. So one will be head, that will be head tail, tail head, or tail tail. So if you count like in how many numbers of this probability there is at least one head, so you'll find 3 of them, right? So the probability of getting first in the head will be 1/2. The probability of getting second time head is 1/2. And also when you see, you are counting this head 2 times, right? Because if you see in this part, this part you will be getting head 1 time, in this part you will be getting head 1 time, and in between, right? So this head is actually at least 1 head, and it is coming under also in the union part, right? We are double counting this head part. So in the addition rule, we have to subtract this double counting part. So that's why we have this final answer, that probability of getting head at least 1 time, that is 1 head, or the other one is head, that will be like this 2/4 out of all the possible outcome, 2/4 plus 2/4 minus 1/4, one possible outcome out of total 4 outcomes. Okay, this 1/4. So in probability there is a concept called independent event and dependent event, right? So if both the events are independent, that means they are mutually exclusive, then their A and B, their intersections part will be 0, so that the addition rule becomes probability of A plus probability of B, and this intersection part becomes 0, right? So addition rule can also be represented as A union B, like I told previously. It is equal to probability of A plus probability of B minus that intersection part. Okay, so here I have taken one more example. So there is a team which plays football, basketball, and some other games. So this is the basic table I have given here. So let's see what comes next here. So in this example, it's asking probability that the team which is playing will be having male, or that male is playing football. Okay, so let's take both these into 2 probability. That probability of occurring that part to be male is A, and probability of occurring that part to be football, that player to be playing football, is B. So if you see, the total number of male players are 60, females are 40, and here I have given total for football is 38, 21 for basketball, and 41 for others, right? So if it says what is the probability of that player to be male, then that probability becomes 60, because male is 60 and we have total 100 players. And what is the probability of that male plays football, that male player plays football, is 38, right? 38 by 100. So if you see, total football players are 38 out of 100. So when we try to find out the intersection, that is both male and he plays football, so if you see male and football, that becomes 22. Okay, so here we have 22 by 100. So again we have to apply this addition rule here. So that becomes probability of male or football equal to probability of that player to be football, probability of that player to be playing, this is probability of that player to be male, and this is probability of that player to be playing football minus that player to be male and football. Okay, so at the end we are getting that probability is around 0.76 or 76%. Okay, so this is the way you apply addition rule. So just remember, so whenever you ask the question of A or B between two events, you have to apply addition rule. And in addition there are two concepts. One is a dependent event and other one is independent events. So for dependent events we will have that intersection part, and for independent events we'll have the intersection part to be 0, right? So let's go to the next part. Next part is the multiplication rule here. So what it says, suppose you have two events and you have to find the you have to find the probability of A and B. In that case you have to apply the multiplication rule. So same goes here. We have two rules. One is for independent and the second one is for dependent events. Okay, so if the events are independent, the formula is very simple. Then probability of A and B will be probability of A into probability of B. So if you take an example here, probability of flipping a coin and 2 times and you'll be getting 2 tails. So here we are having AND condition here, so we'll apply the multiplication rule here. So as probability of tossing a coin is completely independent, so we'll have to apply the independent events multiplication rule here. So it's become simply 1/2 into 1/2, that is equal to 1/4, and it's comes out to be 25%. Okay, in case the two events are dependent, and how to proceed for that. Suppose in a deck of card there are like 4 kings. Okay, suppose someone asks you that you pick a card, the first occurrence should be king and the second occurrence will also be king. So in that case the multiplication rule differs a little bit, because the events are dependent. When you pick a card for the first time, so the probability of that being king is 4/52, because we have total 4 kings out of a deck of 52 cards. So that becomes probability of 4/52, right? And when you go for the second pick, so if you go without replacement, then that becomes a chance of that becomes a dependent event, because you already picked a king and there will be now less number of king and also the number of cards will be less. So this comes that the probability of B such that A already happened. So the probability of A is picking the king for first time, that will be 4/52, and probability of B, that will be the picking the king for the second time, such that the event A has already happened, that is we have already picked the first king. So that comes out to be this. So the final answer is 4/52 into 3/51. You can get the answer using the calculator. So with this dependent events along with multiplication rule, there comes a very important concept that is called Bayes theorem. Okay, so the Bayes theorem states that probability of A happening such that B has already happened is equal to probability of B given A has already happened into probability of A whole divided by probability of B, right? So let's take an example here. Suppose there is a fair dice and there is an unfair dice. Okay, in fair dice, obviously the occurrence of every digits, like from 1 to 6, will be similar, and for unfair dice the probability of getting a 6 is 50%. That is, for a rest of the things the probability will be 50, and for probability of getting a 6 will become 50%, right? So if some example come, like choose a dice, suppose if an example comes like when you roll a dice, that probability that it becomes a biased dice, that is 50% of the time it will be 6, and probability that the dice that rolled is biased and you will be getting a 6. So what is that probability, right? So in that case you go ahead, simply find out all the different parts of this Bayes theorem. So the first part will be probability of 6 when it becomes a bias. So we already know, so probability of 6 when the dice is not fair is 50%, so that becomes 1/2. And when you go to find the probability of A, that is the probability of getting a biased dice, we have 2 dice, right? So one is fair and the second is unfair or biased, so that probability becomes 1/2. The probability of getting a 6, that becomes that probability of getting a 6 when it's a bias, and probability of getting a 6 when it's not a biased dice. Okay, so probability of that becomes a bias becomes 1/2. So you can see here we are applying multiplication rule and probability of bias and 6. So from, and you can obviously get a hint that you can apply multiplication rule here. So bias is 1/2 and getting a 6 in bias is also 50%, that becomes 1/2, plus what, that probability of it's a fair coin, right? Sorry, fair dice, that becomes 1/2, and it become 6. Probability of getting a 6 is 1/6, because in fair dice the probability of getting every digits is equal, right? So there are 6 digits, so probability of getting a 6 becomes 1/6. So here the probability becomes 1/3. So at the end, if you put down all the numbers here, the probability becomes 3/4. Okay, so that's it for this particular video. I hope you like this video, and I will share all my notes in the GitHub, and I'll share the GitHub link in the description of this particular video. Thank you.